Today we will be conducting an experiment to meet the outcome ST28PW, which is describe the characteristics and effects of common forms of energy such as light and heat. Today we will be focusing on heat and one of the effects of heat energy, melting. One alternative conception that students may have had include temperature being a property of a material or object. This was challenged when students looked at how heat was created. Another alternative conception is that objects which keep things warm are sources of heat, when in reality objects that keep things warm trap heat. This is addressed when students learn that insulators keep heat out and conductors let heat through. In the engage phase previously, students were engaged in thinking about animals in different environments and how they keep warm when there is less heat. For example, penguins huddle together. This encouraged students to think about how heat is shared. In the explore phase, students began exploring how heat energy is created through the movement of molecules, as well as different sources of heat energy such as electric and kinetic energy. And in the explain phase, students focused on heat transference and the difference in properties of insulators and conductors. A thermal insulator is good at keeping things at the temperature they are because they do not let heat pass through them easily. So students have an understanding of what heat is, where it comes from, and how different materials may conduct or insulate heat. In the elaborate phase, students will plan and conduct an experiment that utilises their understanding of insulators. They will be looking at how different materials protect an ice cube from melting. The only foreseeable risk from this experiment is the use of scissors, which can be managed by the teacher pre-cutting materials. The aim of this experiment is to investigate whether bubble wrap, paper towel or tin foil is the best thermal insulator. Students could use any different materials in the classroom for this experiment. It is important for students to create their own hypothesis as they conduct the experiment, so my hypothesis is that the tin foil would be the best thermal insulator. The dependent variable in this experiment is the amount of water in the bag after each test. This is what is measured. The independent variable is the insulating materials covering each bag, which is what is changed depending on each bag. And the controlled variables include the amount and size of ice cubes used, the time that the ice cubes are left in each bag, and the way the liquid is measured. So your materials: 4 ice cubes, 4 large size plastic bags, 4 small measuring cylinders. Students may also need a funnel if they need assistance when pouring. 4 thermometers, scissors, bubble wrap, paper towel, tin foil and marker. As I said, any materials from the classroom could be used for this experiment. So our step 1, cover 1 bag with bubble wrap, 1 with paper towel and 1 with tin foil. Make sure that you can still open and close each bag. Scissors may be needed to cut the materials. It's important to leave 1 bag without anything as a control test. So I'll do that now. So step 2, place 1 ice cube in each plastic bag with the thermometer and seal it. So I'll just go get my ice cube. So I'm going to leave these for 1 hour and see what they look like. I will use the thermometers to measure after the hour. So it's been 1 hour since the test. We're going to measure how much water is in each bag. The thermometers that were used, students could use as an extension to talk about the temperatures within each bag. This will then record these results.
These cups show the results of our experiment. The control had 10 millilitres of water melted from the ice, the foil had 12 millilitres, the bubble wrap had 7 millilitres, and the paper towel had 7.5 millilitres. Students will insert this data into our digital technology Visney, which will allow them to create a graph. Students will log in with their Google account and press Create. They'll select the blank template. Once into the creating space, students will go into the Data tab and click Charts, where an editable graph appears. They will go into the settings, type the graph title, fill in the Y and X axis, and turn off the legend. Students can go back to data and input their results. Finally, this can be shared and downloaded to create discussion and comparisons with their peers' experiments.
Students will then discuss the results of the experiment. The results of our experiment show that the foil was the worst insulator of heat. In fact, we know that foil is an extremely good conductor of heat. This is why the foil-covered ice cube melted the most, because it let the most heat pass through it. In comparison, the bubble wrap and paper towel were the best insulators of heat. The materials they are made of, plastic and mainly cotton, do not allow energy to pass through, meaning that the heat from the sun did not move easily into the bag to melt the ice cube. To extend their knowledge, students will then use a simulator that allows them to test conductors and insulators through a circuit. Some of the items in the simulator reflect the items used in the experiment, such as the plastic ruler for the bubble wrap. This will extend their knowledge by relating the experiment to conductors and insulators of heat and allowing them to explore other types of conductors and insulators. The simulation may inspire the students to think about the experiment using other materials to cover the ice cubes, like glass or wood. We found this simulation to be the best because it focused on the conduction and insulation of energy, making it an effective follow-up activity for our experiment. In the next lesson, the evaluate phase, students are given the task to create a shelter for an Arctic animal of their choice. Students will utilize their knowledge of heat energy, conductors, and insulators from the elaborate phase.